Hello, this is Clint. We'll talk today about PythonBasics for 263, our chemical engineering computational tools class. We'll discuss several different basic Python operators listed over here, and we'll go into them in more detail later on in the course, but this is just an introduction. First, assignment operators. And instead of walking you through on the lecture page here, I'm going to open a Colab document and we can run through this together. Here's assignment operator. So here's a variable x that cannot be, of course, a number. 5 equals 5 typed like that is not going to do you any good. But you can have any number of items to text length, for instance, to set different variables. Cast field can be a variable or any number of text-based things. It is case sensitive, so if you do FF is not going to print anything because it doesn't know what it is. So yeah, it is case sensitive on that for variable definitions. This is a conditional statement checking if x is indeed equal to 5. We'll talk about conditional statements later on. I can delete these here, these two cells with this. And data types, Python is nice because you don't have to declare up front what kind of data it is, for instance, or what kind of variable. So the compiler, Python's compiler already knows if you don't put a decimal place after the 5, it's an integer. So for instance, if I add a code and say, hey, just tell me what the type is for x, it will tell me it's an integer. And likewise here, I can take a decimal and convert it to an integer. And notice that integer truncates things. So if I do int of 5.9, that is going to be equal to 5. There are other rounding functions you can use if you want to round something. Int will just do the floor. I think there's a ceiling operator. No, but we'll talk about that later. B is, because as a decimal, is now a float type variable, and this is a string, this is a Boolean, true or false, and this is none type. And that's all shown here, and you can, like I say, do type and E. Put the variable in there and it'll tell you what it is. Tuples. You may not have heard of tuples before, but it's just, it's like a list, but once you make the list, you can't change it, so it's immutable. And here's a little exercise here where we specify it with parentheses and append a 6 to the existing list with this step and create another tuple 7 and 8 without parentheses. So you don't necessarily have to have parentheses. And if I print that with my F statement, tuple is 4, 5, 6, what you see right here. And if I reference it, tuple, this is saying, tell me what the 0th or the first position in the tuple is. What is that value? And it's 4, the very first one. And I can print another tup and what its type is. The value of another tup is just what I set it as, 7 and 8. And it is a tuple. And you can reassign tuples, not what's inside of them, but what the variable is. So that's a difference. So I can't reset, for instance, refer to tuple 0. In that case, tuple 0 is 3. But if I try to reassign it, say I don't want it to be 3, I set it equal to 4, takes this value on the right side of the assignment operator, equal, and puts it in on the left side. And in this case, it gives an error because tuples are immutable. Lists, on the other hand, are mutable. You can change them. Why do you need immutable items like a tuple? It can be very helpful for passing variables into and out of functions. For instance, right here, here's an equation for a mass balance of the liquid and vapor phases, for instance. So that's an example where you can use tuples, passing it to an equation or a function. Here I've got p as a variable, and it's a tuple, and then I pull out the variables outside of that, liquid and vapor amounts, and use those liquid and vapor amounts inside of an equation, for example. Lists and arrays. We'll talk more about arrays next time. Here's just a quick introduction. You can assign a list using the brackets, this bracket here, as opposed to a parenthesis for a tuple. And you can assess the type the same way. It's a list. And you can have list of lists. For instance, here I've got a string, an integer, 2 integers, and then my numbers list that I made before. I put it inside of a list. That might be confusing, but sometimes it's helpful to have lists inside of lists. And you can reference them the same way you can reference a tuple. So this is the second item. It actually starts at 0. Python is indexed from 0. So 0, 1, 2. So it returns 5. And I can reference the very end of the list, this one, going backwards with negative. So there's -1. And if I do -2, it works as well. So -2 returns this one. This is the second one from the end. And once I have a list, I can change it to an array using the NumPy package, or NumPy package. NumPy, using that package, is very helpful and powerful for numerical methods, and we'll use them routinely in this class. So often you will want an array rather than a list. And you can easily convert between the two. Here we're converting from a list to an array with this np.array function, and it converts your list to an array. There are given differences with lists and arrays. For instance, the add function, or the add operator, x plus y, this is x and this is y, they're lists. This will simply append y's list to x's, and you get 1, 2, 3, 4, 5, 6. That's that print statement right here. So I can change that to an fprint statement, doing this, x plus y. And x plus y equals that for lists, so maybe I want to put that for lists. And then here is if I convert it to an array now and add them together, it will add the individual items together, and you get 5, 7, 9. 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9. Dictionaries. Dictionaries are an assembly of key and value pairs. Here's the key, and here's the value. The value does not have to be a number. It can be a string, for instance. String. And here I printed out what the key value is. A, it printed 1. And you can access them in different ways, like in this gets the key value and returns the value for either one of those methods. Dictionaries are very helpful, and we'll talk about them as we process data. Loops, key in programming. And here we set up an empty list with brackets, And now we are simply using the lists method of append, and you can append I squared to the list, and then it will print it once it's done with this loop. So this for I in range 5 does the loop 5 times. So I can print out I, and it'll tell me what that is for each iteration. So the first time it does it, comes in here, prints I is 0. I starts out at 0, and then it does 5 times because the range is 5, and appends to the list 0, and then 1, and then 4, 9, and 16. If we run this cell again, what's going to happen? Same thing, right? Because I reset my list right here. But if I take this out, if I just remove this and run it again, now I didn't reset my list, start it over, initialize it, and I've got 5 additional numbers according to what it appended to the existing one. There's while loops as well. It will do a certain action a number of times based on a conditional statement, and that leads into our conditional. There's other ways to generate lists as well, or loops. You can do inline loops. Here's an example of an inline loop. You can learn about that as we go forward. This is just an introduction and conditional statements. You can check if x equal to 5. If it's not, it'll do the other operation. Else, if x equals 4, it will do this statement. Otherwise, it'll do this statement. And you have to have them properly spaced for this to run. Otherwise, it won't run. So you have to line them up. And x equal to 4, it checks it right here. So it does this, does not do this, and exits the if statement once it's done this action right here. If I change this to 8, then it's going to check, nope, it's not 5, it's not 4, it's going to do this else statement here. And it's not 4 or 5, it's 8. Objects. Objects are very powerful. Objects are, we've already discussed them. A list is an object. And with that object comes methods. So we use the append method of the list's object and appended items to the list. You can create your own objects just like a list, and it can have properties. Like, for instance, we create a person and initialize that object, and we tell that class how to do that, and it has a name and an age. And you see how you use dot notation to set what the individual properties are. So now this person has a name and an age. And I can say Joe is a person, give his name and age, and it will run that and print out Joe's name and age. I could change it to 23. And that's how I initialized objects. And there's also, in this class, I recommend you use the param package. It makes things straightforward in terms of making sure you initialize things properly, setting up default values. So this is a default value for each of the parameters that's part of this. In this case, a gas has a molecular weight, temperature, and pressure. And so and it also has a method here, or a function, to define what its density is based on its temperature and pressure. And then you can create the object air, for instance, give it a molecular weight and a temperature, and it'll print out its density. You'll find its density if you call that method. We'll talk more about that. Bits here. So computers are made up of transistors. I got to work at Intel, got to make some computer chips, and there are a lot of transistors on your computer, and it's made up of ones and zeros, or the on-off, 1 on, 0 off. So here's 3 bits. So one of the transistors on, next one's off, and the other one's on. That can represent a number. In binary, if you go 2 to the 0, 2 times 1, which is that first item, 2 to the first power times 0 is the second item, 2 to the second power times 1 is the third item, and that gives you your number. And there that is. And one way to do it too is this integer function, changing it from a string, telling it it's a base 2 number, and it will do the same thing as this here. And the bin function is internal to Python. It can tell you how many bits are needed and what their values are for the number 5. So here this is 0 meaning a binary, and B meaning bit, 101. So that's the same thing we got up here. And you can use that and specify a function to calculate the bits for any given number. So for 255, it's 8 bits you need. And to see what those bits are, you can do bin 255. They're all on for 8 bits. God lives and loves us.